We are back in the video. I apologize for the delay. I think there was an issue actually on my end with the setting that has the best streaming thing set up. I had one of the settings set so that it was easier to chat, but I dedicated more of the settings to hoping that that would improve the video quality. So I'm going to give people just a second in case they want to come back. And just so you guys know, the question Q&A section is still open, so you can still post some stuff there. Again, I appreciate you guys' patience in this. This is the first time I'm doing this, so I'll figure out the best way to do this. But yeah, I'll give people a second to join back if they'd like. Looks like we got a couple people that came back. Thank you guys. Feel free to continue to let me know if the video is still giving you some issues on my end to see if I can improve that. So far we got 2 people. So I'm gonna go ahead and pick up where I left off. Again, you guys can post some things if you'd like, including if there's video quality issues. So we left off with this problem here. And I was just in the middle of explaining how to get this point here. So I took the angle of pi over 4, I put it into theta, and I got out 0, right? So I would just continue to do that, and I'd find the other r values for each theta value. So for example, if I plug in pi over 2, times pi over 2 is pi. Cosine of pi is -1 times 3 gives me -3. Okay, so this is a r value of -3. If I plug in 3 pi over 4 here, I have 2 times 3 pi over 4 is cosine of 3 pi over 2 is 0. And then if I take pi and put it in here, cosine of 2 pi is 1. Is +3. So there's our couple points there. So I'm going to graph it on the next page. And our max r value, as you could see in the table, is going to be 3. So I'm just going to draw some tick marks out to 3. And then I'm just going to go through and use these values here. So out 0, angle of pi over 4, well, that's just going to be the, whoops. There's my first point. My next point, I have left 3 pi over 2. So remember, I stressed to you guys that this means 90 degrees from wherever you're starting at. So if I'm on the left side, 90 degrees counterclockwise. So I'd go 1, pointer, 1, 2, 3, left 3. 90 degrees from here puts me down here. So I have a point, add 1 right there. And that's going to be my first pedal. And then I have, this is going to be the origin repeated. So the next one is right 3, angle of pi. Right 3, 1, 2, 3, angle of pi. I move over here. So I got a point there I can add. Now from this point, I can continue to make my table if I want. I've used all my points. If I want to add some, I can. But the easier way is to realize, again, there's 4 pedals, and we know there's some symmetry here. So you can guess that the other 2 will be here. And that'll finish off my nice rose curve, okay? So again, notice how I have the symmetry here. In addition to that, I have cosine. Cosine will always have at least 1 pedal, in this case 2, on the x-axis. By the way, that is not true for sine. A sine rose curve will not necessarily have a pedal on the y-axis. That's just a pattern that you'll notice for cosine. Okay. See how we're there. Oh, thank you guys. Okay. Well, there's no more questions that have come. Thanks for the person that said they appreciated it. I appreciate that comment. So yeah, if you're looking at the rose curve here, also do, and this is a question that was kind of showed up on your review sheet, is you can take just a piece of this graph and maybe think about, well, what would I have to limit these angles to say, I don't know, maybe get just the top petal, or what would I have to limit these to if I wanted to get just the right petal or just the left petal, or maybe just two of the petals, right? So let's just kind of walk through this and see how I could do that. So for example, for these values I had here, notice that origin point, this point was right here. So let me actually just highlight that in a different color. So this was one of the points from our table, which gave us one of our petals, right? So for example, what I could say is, okay, well, if I limit theta between pi over 4 and pi over 2, get, right? So if I say let theta be between, again, going back to my table, pi over 4 and pi over 2, right? So let theta be between pi over 4 and pi over 2, right? Well, this, I try my best to keep the same blue color here, but this color here corresponds to just this petal. So if they said something like, what would you have to restrict the angle to just get the bottom petal? Okay, now it turns out that there's more than one answer, number of answers. You could find different increments that are similar to this once you go around and do the rest of the rose curve, but this is good enough, right? We just got from our table that if I limit theta between these 2 points, petal. Okay, so that's the type of question you might run into. Just keep that in mind, whether it's a rose curve or a cardioid, like on the review sheet that I gave you guys. Okay. So yeah, that's one of the questions they could ask, especially related to graphing. They really like to ask those. Okay. So unfortunately, I was planning only to be here till 8:30. I'm going to add a couple extra minutes since you guys came back, and I appreciate your patience. So I'm going to do at least one more question. Thinking back to the review sheet and what we've done in class, I know that a lot of people have a lot of good questions related to, converting from polar complex to Cartesian complex. So let's do an example like that, right? So let's say that I'm given, I don't know, let's say -√3 plus, or even let's make it minus I, right? So first of all, remember that this is called Cartesian complex. Okay. Sometimes you'll also see it as rectangular, and then a third way, not as often used, is known as standard. So just keep those vocabulary terms in mind. So the question is, it's actually similar to the first question, from Cartesian to polar, right? So if you remember the first question we did back here, we did sort of, remember this is the website if you guys want to post questions, but we did a conversion from polar to Cartesian equations, right? So now we're doing Cartesian polar, just coordinate points. So it's a little bit different than just the equation conversion part that we've done in the past. Okay, so to do this, remember that the form for polar is always going to be r of theta plus I sine of theta. Okay, so to find r here, I'm going to use the formula, which actually comes from the Pythagorean theorem. You can use that to help you remember it. And I'm going to put in my here and here into each of these square slots. So by the way, remember that this will always give you a positive outcome. A negative squared becomes positive. Square root of 3 squared is 3, right? A squared and a square root undo each other. And then I have 2 squared is 4. And then the next one I have here, negative squared is positive, and 2 squared is 4. So I'm just squaring everything that's inside of there, right? Got square root of 4 over 4, which is square root of 1, which is 1, okay? now I have the R value. The next step is I need to find theta. So if you go back and look at your notes, I think we called this like step 1, find R. Okay, and then step 2 was find theta, right? Because remember the ultimate goal is to get it into this form. So I need to find R and theta. Okay. So when you're doing this, you want to make sure that you always are using the example of, sorry, I'm kind of sidetracked here. I'm looking at the questions. Can you show how it would work if there were 3 petals and the period was 2 pi over 3? Yeah, so anonymous user that posted about the 3 petals, I will do that absolutely. Finish this question and then we'll get to that one right away. It's a good question to go over. So to find theta, I'm going to use tangent inverse. Okay, and I'm going to put the positive version's coordinate point up here, down here, right? So I made them both positive. The second one goes on top. When you simplify this, right, you're doing a fraction divided by fraction. So I do 1/2 times the reciprocal of this. And I'd encourage you to do that workout on your sheet of paper, whatever you're following along with, and you would see that you would get 1 over the square root of 3. So I can actually use my calculator to help me as well. If I do tangent inverse of 1 over root of 3, let me see what that would be. That would be 30 degrees, okay? I made a note about this in class. A quadrant 1 angle, right? The quadrant 1 angle, if you go back to here, this is actually a quadrant 3 angle, right? So to find the actual theta, I would have to take 30 degrees. And remember that the rule for quadrant 3 is 180 degrees plus theta, or what we usually call theta prime, right? So if I call this theta prime, there we go, okay. 210. So in the end, my answer would be 1 cosine of 210, 1 because that was my R value that I found, plus I sine of 210. Now, because this is 1, I don't necessarily have to have the 1 there. Sometimes it's root 2, sometimes it's 4, but you can just leave it like that if you want. Remember that if they ask you to put it to rectangular or back to Cartesian / rectangular, all those same vocab terms that mean the same thing, if they ask you to do that, take what is cosine of 210, what is sine of 210, distribute that 1 here, okay? So I'll let you guys do that because I want to get to that question about the 3 petals, but that's kind of the gist of that type of question, okay? So let me go back and look at this question. So someone said, can you show how it would work if it was 3 petals and the period was 2 pi over 3. So 3 petals and 2 pi over 3. Okay. So get that. Okay. So thank you for that question. That's a good one to look at. So let's say that this was, let's use the same thing, but maybe a negative, and let's make it a sine. And we'll have a 3 theta. Okay, so that the question that person was asking is, you'd have a period of 2 pi over 3, right? Where this 3 is coming from this 3, right? 2 pi over the number next to theta. And that gives you your period for sine and cosine. As that person mentioned, this is a rose curve with 3 petals, right? Because this is an odd number here. So like I said in the last problem, that will be the number of petals. Through our R and theta table. And so I'm going to put my period at the end here, just like we normally do. Now, again, if you need to do this work out, you should. I'd encourage you to do that just to make sure you don't make a mistake in your values. So halfway point of 2 pi over 3. If I do 2 pi over 3, 2, right? That's 2 pi over 3, 1/2, right? Because this is really over 1. So I can make it as a fraction divided by a fraction. And then you see that the 2's cancel and you get pi over 3. So that's my halfway point. So let me just do that again. So I took 2 pi over 3 and 2, and I noticed that, or remembered that 2 is the same thing as 2 over 1. So I'm doing this fraction times the reciprocal of this one. And I'm left with the pi over 3. Okay? And then if I take half of pi over 3, 6. And then to find halfway between these 2 points, you would add these two. Get 3 pi over 3, which implies the pi. And now I cut that in half, which is pi over 2. Okay, so that gives you your setup there. Okay, so that would give you your angles, and now you can go back and find your R values. Okay, I'm going to stop with that problem unless there is any other questions. Let's see. Doesn't look like there's any other questions. So this question, since that was the last one that was posted. So if I have these as my you guys give me one second. All right, guys, I'm back. I apologize. Somebody was at my door. I had to answer it real quick. So where did we leave off? All right, so for graphing this, I have my theta values, and hopefully you guys can't hear my dog barking in the background, but you probably can. So I'm going to take pi over 6, plug it into the theta here. So 3 times pi over 6 gives me pi over 2. Sine of pi over 2 is 1, times negative 2 is negative 2. 1 pi over 3. 3 times pi over 3 is pi, is 0, times negative 2 is 0. Pi over 2, 3 times pi over 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1, times negative 2 gives me positive 2. And then, as you can probably guess, this last one is 0. So now if I graph this, maximum value being 2 for the R's, and we'll just go through and do this real quick. So if I go left 2, pi over 6, pi over 6 is 30 degrees. So I go left 2, just kind of estimate it here since I don't have polar paper. Okay. Next one I have 0, pi over 3, that's the origin. So now I see my middle here. Okay. Next one I have 2 and 90 degrees. So if I go up here, I have right 2, 90 degrees. Remember, you're going counterclockwise for all these angles, right? And then again, using the symmetry, we see that there's 3 petals, and we want it to be symmetrical. So you can probably guess that the other one is going to be over here, right? So that it has the symmetry sort of like a fan. Sorry for my uneven blades here, but you guys get the idea. Okay. So that would be an example of the 3 petals. So the person that posted that, hopefully that answers your question. Example of a rose curve with 3 petals in a period of 2 pi over 3. Okay. Okay. So you guys, thanks for watching. I appreciate your patience again. These videos are going to be up on my YouTube page if you want to go back and see them. Okay. Again, in the future, hopefully you guys found it helpful. Feel free to give me feedback either on the page, or even better would be in person. Let me know how your experience was. To give you guys the ultimate opportunity to get your questions answered and feel comfortable and ready for the test. So I hope that's what this did for you. Again, I appreciate you guys coming back. See you in school tomorrow, if not on Friday, because some of you I don't see because of the testing schedule. Remember that schedule's different tomorrow. Okay, so I hope you guys have a nice, and I will see you soon. Bye-bye.